Hey guys, so this is going to be the first video of our complex numbers series. Now, I'm not going to lie, the complex numbers is a pretty hard topic, so we're going to have to assume that you've already learnt high school level algebra, trigonometry, graphs, and geometry, or everything that appears on your screen right now. But otherwise, we're going to start completely from scratch, so this series is perfect for you if you're just coming across the complex numbers at high school or uni, or maybe you're about to and you just want to get a head start. Or you can even use this series to revise the complex numbers for an upcoming test or something else like that. Now, before we get to the complex numbers, we're first going to have to look at the different types of numbers. So the first type of number are the natural numbers. Now, these are your positive whole counting numbers, like 1, 2, 3, 4, 5, 6, etc., on to infinity. These numbers are really useful, right? I mean, you can add them, you can subtract them, you can multiply them, and so on. But you do run into some big problems very quickly with these numbers. For example, what if I ask you, what's 3 minus 4? Now you know that 3 minus 4 is minus 1, but what exactly is minus 1? I mean, you can have 3 friends, you can have 4 friends, but you can't have minus 1 friends. So what is minus 1? How do we think about minus 1? Well, one way to think about minus 1, or negative numbers in general, is as debt. So for example, say you owe your friend 50 bucks. You can represent this mathematically as having the number negative 50. And so in this way, negative numbers can be very useful, even though in other certain cases they can be very strange. Now, another type of numbers are the fractions. You come across these guys when you ask questions like, what is 2 divided by 4? Now, you guys know this to be a half, but again, what is a half? I mean, you can have 2 friends, you can have 4 friends, you can have 500 million friends, but you can't have half a friend. But fractions can be very useful in other situations, such as when you're converting currencies. So in this example, 50 cents is equal to half a dollar. So just like the negative numbers, fractions can be very strange in ordinary cases, but they can also be very useful in special cases, like converting currencies. Now let's keep going by asking, what is the square root of 2? Now the square root of 2 is not a fraction, it's not a negative number, and it's not a natural number. It's actually its own type of number, which we call a surd. So the surds are numbers like the square root of 2, the cube root of 77, the 68th root of 2 plus 36, and so on. Or in other words, they're what you get by mixing the fractions, negative numbers, and natural numbers with things like square roots, cube roots, and any other type of roots. And just like the negatives and the fractions, the surds can be very strange. I mean, you can't have root 2 amount of friends. But they are especially useful in geometry. For example, if you want to build a right angle with just a ruler, you can do this by measuring 2 lines of length 1 meter and 1 line of length root 2 meters. Put them together like this and you'll get a right angled triangle. There are also other types of numbers that aren't any of these. These numbers are called transcendental numbers and include numbers like pi, the circle constant, and e, which you come across when dealing with logarithms, as well as many others. Now, all of these types of numbers that we've gone through here are actually part of a much larger group of numbers called the real numbers. So the real numbers are just a collection of the natural numbers, negatives, fractions, surds, and transcendental numbers put together into one. Remember this because it will become important later. Okay, now we're ready to look at the complex numbers, because just like when I asked you what is the square root of 2, what if I ask you what's the square root of negative 1? At first, you might say that it doesn't exist, but what if, like the negatives and the naturals, it can be very useful in certain situations? Okay, fair enough. Let's try playing with the square root of negative 1 and see what we can do with it. So the first thing we could do is we could multiply it by itself, which will just give us the square root of negative 1 squared, and the square would cancel out with the square root, giving us just negative 1. So the square root of negative 1 times itself is negative 1. But if we look here, what we have is the product of 2 square roots. And there's a rule in algebra that says the square root of a times the square root of b is equal to the square root of a times b. So let's use this rule here, and so we'll get the square root of negative 1 times itself is equal to the square root of negative 1 times negative 1, which is just the square root of 1, which is just 1. But before we said that the square root of negative 1 times itself was equal to negative 1. So that would mean negative 1 is equal to 1. But how can this be right? This is a very big problem. When this kind of thing happens in math, we call it a contradiction, and it actually means something has gone horribly wrong. So you might be tempted to say, that settles it, the square root of -1 doesn't exist. But if we look back, you'll see that the only problem really occurred when we used this rule. And as a matter of fact, that is exactly where the problem lies. This rule only works if a and b are positive numbers, but since we used it when they were both negative, we got a contradiction. So whenever we use the square root of -1, we have to be super careful that we don't accidentally use this rule. Otherwise we get things that are absurd, like -1 equals 1. Naturally, it would be really helpful if we could find a way so that we can't use this bad rule. And one way to do that is to let the square root of -1 be a letter. Now we can let it be any letter we want, but usually in math we use the letter I. So we're going to set the square root of -1 equal to I, or in other words, I squared equals -1. And instead of writing the square root of -1 from now on, we're just going to write the letter I. And because the letter I doesn't have a square root sign with it, we don't have to worry about this rule since it only applies to the square roots of numbers. And so that's why in math we always write I instead of the square root of -1. But the awesome thing about I is that it's not part of our collection of real numbers over here. It's actually its own type of number, which we call an imaginary number. In fact, the imaginary numbers are all the multiples of I. So 2 times I is an imaginary number, along with -43/77 times I, and pi times I, and so on. In general, an imaginary number is a number in the form r times I, where r is one of our real numbers over here, and I is of course the square root of -1. So r times I, or Ri for short, is how we define an imaginary number. Alright, that's cool, but it gets better. What if we combine a real number and an imaginary number together? So for example, what is 1 plus I? Or what about 3 minus 7/9 times I? Or pi plus I? Now we've gone into complex number territory, because that is exactly what the complex numbers are. They are numbers with a real part plus an imaginary part. So for example, take the complex number 2 plus 3i. The real part is going to be the number 2, while the imaginary part is always the number next to the I, which in this case is 3. So in general, a complex number is a number that can be written in the form a plus bi, where a and b are both real numbers. Furthermore, we say that a is the real part of our complex number, while b is the imaginary part. Or in other words, the imaginary part always has the I next to it, while the real part never does. Be careful though, because the real part isn't always the number on the left, and the imaginary part isn't always on the right. For example, let's take I minus 7. The real part here is actually -7, because it doesn't have an I next to it. Meanwhile, the imaginary part here is in fact 1, because there is secretly a 1 next to the I, which is hidden because we don't write 1i minus 7, since multiplying by 1 doesn't do anything. Right, so that's it for this first video. Next time we'll be taking a look at doing arithmetic with the complex numbers. See you then!